Okay, so thanks so much for coming. So as I was saying, like the goal of this presentation is really to focus on the theoretical aspects of the work that we're doing in the Department of Play. And, uh, and personally, I think there are many theories that inspire what we do. And, and, uh, and for me, it all started when I did my master thesis in Brazil between 95 and 99. And where I came from a software engineering background into education. And when I start looking at the existing tools that were made for teachers and students, I couldn't really understand what was special about them there. And then and I was trying to learn how is it that people design software for education. And I couldn't figure out any existing methodology that actually described that in a language that would be understandable by software engineers, but it would also be understandable by educators. That was a big surprise for me because there's so much discussion about technology for education, right? And then I realized that that might be a big issue for not just for me, but for many others. And I thought to spend some time focus on that. And that's what I did as part of my thesis there. So there's a lack of specific methodologies, right, for that aim at the design of software for education. And so the goal of this particular work was to propose an approach based on activity theory. I'm going to describe more what that is. And then analyze the application of that approach on the creation of a workshop with children, in which they use a tool called Coco that was later released as a Stagecast. Uh, and I think one of the key insights for this work is that there's no given software or technology that's by itself able to educate a person. Right? You cannot guarantee that you're going to sit like a child in front of the computer and run a given application, like a specific software, and that software is going to make the child learn a specific thing. You cannot guarantee that, right? And in special, I think if you sit down like a child in front of a computer and open up a text editor like Word, for instance, and ask that child to write a text or to copy a piece of text from a book, or if you ask the same child to write about his or her dreams, you're going to get completely different outcomes from that, even though it's the same child and the same software. Right? So what really matters in education is the activities that we develop for, for our learners. Right? And when you think about technology, technology is going to be more or less educational, depending on how well or not it supports that educational activity. So you cannot say that the computer is educational. Might be educational or not, depending on how well it supports what you're asking like the students to do with it. So that was a key insight for me. And so in this work, the hypothesis is that activity theory is something that can help us describe educational activities. Because one thing is to say like educational activities are key for learning. The other thing is to be able to describe what are the important aspects that need to be considered in that activity to make it really learnful or not. Right? Um, and then the question is, so how can we describe educational activities in ways that people can understand, right? And what's the specific role of computers and other new media, right, within those activities? Right? Because like, I think it's very interesting to notice that like, when people talk about computers, even though they're pointing to a machine, they're usually referring to different aspects of the tool. Sometimes like you're playing a video on the computer. Are you using the computer as a computer or a video player? Playing audio there, or running a simulation. Are you using the computer for what it's actually good for, or are you using just to replicate some other existing artifacts? And I think it's very important to distinguish that. So when we think about computers, what is it that we're talking about? Because if I cover my screen, if I cover this machine with a piece of cloth and only display the screen, might be a TV, might be a VCR, might be something else, a camera, right? And then so what is it that characterizes a computer that everybody talks so much about? And so activity theory is Even though it's not very popular in the West, have you heard of activity theory before? Have you heard anything?
I think a little bit.
Yeah. Have you heard of activity theory?
I, I don't know. I mean, sometimes the words are different, but
Yeah.
I listen to you.
Yeah, so
Tell you
activity
afterwards.
theory is, people say, is one of the central tenets of Russian psychology. It came from the line of like a Vygotsky and Leontiev, and there's a whole school that came from there. But sometimes when we study like that period of Russian psychology, we tend to focus on Vygotsky, per se, or Leontiev, but not what happened afterwards. And there's so much, and that evolved into what they call activity theory there. And it's a multi-interdisciplinary body of literature that studies human activity in general, right? And especially all the historical and social, cultural dynamics that affect the way we interact with the world and how we develop ourselves as part of that interaction in there. And in the early 90s, it started getting some space in education and in the design of computers, and especially in the part of human-computer interaction. And that book that I have on the table, like Context and Consciousness, that was published in '96, was one of the first, I think, that actually made the case for activity theory in the design of user interfaces. But basically, when you look at an activity from the top, right, it's basically uh, a set of actions that are performed by individuals on objects. So you have like a subject working on objects trying to produce something that's either address a need or a desire that you have. So I'm trying to build something that's going to fulfill one of my needs. And the interaction with these objects is mediated by artifacts. Artifacts can be physical tools, for instance, but it can also be psychological, like different methodologies or approaches that you use to solve a problem, for instance, that mediate the way we interact with the things that you're playing with in the world. And interaction with objects is also mediated by a community, right? So the different people that surround you that are also sharing access to that object. And also by rules, so the way the activity should be conducted, like a duration, and etc. And the division of labor, or the different roles that people might are allowed to play in the process of executing the activity. So like a learner might be allowed to perform certain actions in a classroom, whereas like a teacher is allowed to do something else. And that's defined in the division of labor, like the different things that you can do according to your roles in there. And each activity is also analyzed according to these like 5 or so dimensions. The first one is the hierarchical structure of the activity. So activities there, they can be broken down into actions, and actions can be broken down into operations. So activity is the higher level, like actions are the different steps that you're conducting to execute the activity, but operations are are more unconscious to us. Like actions that are being executed so many times that you don't have to pay attention to them anymore. So when you're learning to drive a car, at first you have to pay attention how you shift gears, how you're turning, you have to look at the mirror, you get confused by all these things. But once you get expertise with these things, all of a sudden you're shifting and you're turning without really paying too much attention to that. You start focusing on more higher level goals of what you do, like more like the route or people passing on the street and etc. But all of a sudden, for instance, when you get into a new car or you switch from one kind of road to another, all of a sudden you have to relearn these things. And then those operations that were unconscious become conscious again. So there's like this interplay between actions and operations and etc. And in the case of learning, when you're creating an educational activity, we have to really think very carefully about what is it that we want students to be conscious of, and the kinds of things that we want them to not necessarily pay too much attention to in there. So have them to focus on a concept on the screen, or if they're distracted by a mouse or like a mouse on the computer, or something else, something on the screen that they don't really understand, they might distract them from the activity, right? Another thing that we have to consider when analyzing an activity is levels of internalization and externalization. What is it that we want people to internalize? What is it that we want them to externalize? So that others can actually work with them. So as a teacher, you like your students to externalize certain things so that you can actually help them in the process of learning and get a better sense of how much they learned, how much they didn't. Right in there. So that's something also to be considered. A third dimension is what they call object-orientedness. And that has to do with the different kinds of objects that you're going to be playing as part of your activity, and how meaningful or not those objects are to the participants of the activity. Right? One thing that I find interesting is that you might, like if somebody gives you a pen, for instance, for the birthday, you know, that pen has a very special value to you. You know, you might have like another pen that is exactly the same, but the one that you got from your birthday has a special meaning. And that's something that you also have to consider when you're dealing with learning. Right? Different objects have different meanings for different people, for our students. And for instance, like the computer, it plays a very important role in our society. You know, it's like a symbol of status and everything. So we're working, especially working with children in more underserved areas. If you say, oh, here's like a cell phone, or here's like a computer, you're playing with different values in there that go beyond what the tool does, per se. So these are kind of things that you have to consider. The fourth dimension is history and development. And history has to do with these historical constraints and other things that we have to respect when we're implementing an activity. Like, for instance, if you're going to work with a school, you know, the schools, they have sessions that are like a 15-minute long. If you expect your activity to run for like 2 hours each day, you're going to go against something that was predefined in there, and you know, might not be very productive. So you have to be very careful in terms of understanding the historical limitations that you're playing with, the things that you can actually change, the things that you cannot change, right? And also another thing along the same dimension is the development of the participants throughout the activity. The first time that you run an activity with children, for instance, they're going to behave one way. The second time that you do the same activity, it's going to be very different. You know, or the first time that a person touches the computer is very different from the second, it's very different from the 100th time. Okay. So when we design the activity, you have to think, how is it that each one of those elements are going to change over time in there, and provide different kinds of support for them along the way. And the fourth is mediation, which has to do with the role of the different kinds of artifacts that you're going to provide as part of the activity, and how much they're going to filter or not of the interaction that the people are going to be doing, having, or all different kinds of objects, or the community at large. Yeah, so this is very high level description about activity theory. And in the case of this particular thesis, I used activity theory to try to model a specific kind of learning that's called constructionist learning. That was, it's a theory that studies how technology can be used in the creation of educational environments. Right? It was developed by Seymour Papert from the Media Lab, like in the early 70s. And it became very famous, mostly because of Logo, the Logo programming language. Are you familiar with Logo? And Logo is pretty much is a programming language, the graphic or Logo, or the turtle geometry part of Logo. It's a language in which children program a little turtle on the screen. And they have some basic commands that they can essentially ask the turtle to do, such as move forward 100 steps, or turn right 30 degrees, move left, backwards, and etc. Change color of the pen. And the idea here is that by playing with the turtle, kids will automatically learn some basic geometry concepts. Because no matter what you do with that, you're going to have to play with those commands. Right? Move forward, turn, change color, and these things. And then you're going to start drawing things on the screen, and after a while, you're going to start learning some the relationships between the number that you put in there and the distances that the turtle move. We're gonna eventually realize that like a triangle has like 3 sides, like a square has like 4 sides of the same size, and etc. Right? So they create like this whole environment where you play with this little object on the screen using like these sort of artifacts that are the commands. And in the process of doing that, you go from something that you like or that you know, like the turtle, and then you start exploring something new to you, which is the geometry of space. And that was very revolutionary, like at the time when people were really thinking more in terms of using computers to replace teachers and creating these like intelligent tutoring systems. All of a sudden, like Seymour proposed something that was very different, in which children will be teaching a turtle how to move on the screen, and in the process, they'll be learning a lot of interesting, I think, or powerful ideas. Right? But the problem is that a lot of people start associating constructionism with logo. And they thought that everything that you have to do with children has to use logo. You have to use the turtle. So let's explore like issues of the city. So let's use logo to draw the city and do everything. And then we spend like a month trying to draw like a building or a car that moves on the screen, etc. I mean, you learn a ton by doing that, but is that really the point, for the activity, right? And so what wasn't clear, I think, for many is that construction in the practices goes way beyond logo. Logo is one example of could be done. But people couldn't really figure out how to go from logo to something else. Like if logo was designed to help people learn about geometry, how can we design something logo-like to help people explore something else? Like geography or civic engagement and other things. Right? So that's the challenge. And there are no methodologies, as far as I know, they teach people how to do that, which is too bad. So in our case, we use the activity theory, like all the different social, cultural, and historical dimension that it brings, to analyze a constructionist activity and use that to create new tools and a new workshop based on that. So I'm gonna in traditional software development, people tend to follow a cycle of these 5 steps. There are different names for them, the different ways that the cycle is represented. But basically, when you start developing a software, there is a period of analysis where you start to describe what you want to do. And then after you describe the kind of tool you're going to implement, you design that, how you're going to implement that tool. And then you actually develop the software. And then you go test the software. And then you deploy the software. And then there is like a period of maintenance. So you try to fix bugs and improve things, and etc. And this cycle can be longer or shorter. You can repeat it a million times until you get something done, and etc. But that's the basic approach. In the case of this methodology that I proposed in that thesis, we start by analyzing the educational activity, describe what kind of educational activity you want to develop, right? And then we analyze the role of the computational artifact inside that activity. And once you do that, you can start actually designing the software. But the software has to be implemented within the description of this much larger context. You have to understand how it's going to be used, how is it that like the learners are going to evolve over time, what are the historical constraints that you have, etc., etc., etc. But once you describe that, and then software engineers can actually go and actually implement something. Right? And they might be able to understand what are like the different trade-offs that have to be considered in the tool. And then, so in the first phase of this cycle, in the analysis of the educational activity, we describe the activity in its 5 dimensions, right? And there's a generic and a specific part here. The generic part is independent of the context. So there's like a generic constructionist activity. It has to follow such and such guidelines, right? But once you implement that activity in a school environment, right, you have to focus on the specific aspects of that kind of environment. And if you do a different activity for like an after-school center or focus on a different domain, right, you're going to have to specify the specific characteristics for that environment. but they all share like the same generic description. Okay, that's usually described in articles or books, etc. And then after you define the activity itself, you can start analyzing the role of the computational artifact inside the activity. So in this analysis, we try to analyze the role of computers in there. And in this case, I differentiate, I try to open up the concept of computers into 4 different concepts. One is what we call the computational artifacts. The other is digital artifacts. The third is digital objects, and the fourth is applications. Like, let's say that a digital object can be a movie, for instance, or an audio file, a digital object, just like a piece of content in there that's going to be manipulated by students or teachers. Digital artifacts can be players for that content. You can have like a media player of some sort. But a computational artifact is a special kind of a digital artifact, but it's programmable. So if you can program everything, in this definition, it's a computational artifact. That's the biggest difference between a computer and other devices, that you can program. It has basic operations defined, but you can combine these different operations into something larger, that do something that is specific to you. Right? So if you want to use computational artifacts in an activity, that means that somebody is doing some sort of programming. In the case of logo, for instance, people were programming the turtle. They're combining the different commands that the turtle understood, like move forward or turn, and repeating that several times, right, to create like a procedure that they call house, for instance, or a game. You know. And applications are just like combinations of those that we package together. So when you buy an application from Apple or somebody else, right, it comes with a different set of digital objects in there that you can manipulate, like little characters or video and audios or even simulations, and then tools that let you manipulate those objects as like almost like digital gloves that you use to move things around. And for each dimension of the activity, we have basic questions that we should ask ourselves when we're designing this thing. So, what's the activity? What are the actions that each actor is going to perform in there? What are the roles? And then what are like the different actors that the tools are going to support in there? What kinds of operations should be automated or not? In there. So like, what is it that like the students are going to be doing? What is it that the teachers are going to be doing? No, and then how is it that we're going to support them with our tools? What kind of concepts, skills, or attitudes are going to be internalized by each actor of the activity? So what is it that we expect the students to learn in this case, or even the teachers to learn, part of the process, right? How is it that the tool is going to support that? What is it that people are trying to achieve with the activity? You know, what is it that they're trying to do with that? What kind of objects they're going to be manipulating as part of the process? You know, and then what aspects of those objects are the most relevant for each actor? You know, is there anything there that has like a personal meaning to people that's going to motivate them in different ways or frustrate them in different ways? That you want to use that in our favor, you know, to actually guide them somehow. And how is it that the different tools are going to support, you know, the focus on different aspects of the objects that are part of the activity? And for the history and development dimension, how does the activity evolve over time? You know, we're going to have like 15 sessions. What's going to happen, you know, in each one of those sessions? Now, how is it that the different elements are going to change in the activity? Like, how is it that the students are going to change from the first time that you meet them to the last session? How is it that the objects are going to change, right? For instance, we're going to be creating games with children, right? The first time they're going to see a blank screen, but the second time that they use our tool, no, they might see the project halfway done because they already worked on that before. or, or something else? Are they going to be exposed to something that other kids have developed or not? You know, these different things that have to be considered. And as always, how is it that the tool is going to support that kind of thing? What kind of elements are going to mediate interaction between the different actors? You know, are the students going to interact with the teacher face-to-face? Or are they going to interact with the teachers via email or chat? Or, you know, what is it that, are they going to write papers? How is it that people are going to interact with one another? How is it that students are going to interact with one another? Right? And what aspects of the interaction are going to be supported by the tool, the software? Right? What aspects of the interaction are going to be constrained by the tool that we don't want people to use? Right? So getting those questions into the constructionist paradigm, like a generic constructionist learning activity can be described like this. You have like learners interacting with what they call transitional objects, trying to implement something that's personally meaningful to them. So I want to draw a house using the turtle in that. So I'm building something that's very meaningful to me in that. And the interaction with those objects is going to be mediated by computerized and non-computerized artifacts. So it's not that all the constructionist activities have to use computers, right? In some cases, you can get kids, you can build like a maze on the floor using wood, and then you can ask kids to pretend to be the turtle, for instance. And then one kid, say, controls the other kid, you know? So let's say now, close your eyes, move forward 5 steps, turn right 30 degrees, you know, move backwards, and the goal is to go across the maze to the other side. This is a constructionist activity, you know, that's very personally meaningful in some ways. It's fun and etc. But it's not using computer at all. In that. And then in the case of constructionist activity, there are different roles that people might play. They can play the role of learner, a facilitator, a source of reference. So if you have a question about something, it can be either a generic actor or the designer of the activity. So some teachers might design the activity itself. Others might just use some ready-made activities, for instance. And the rules include like the duration and amount of sessions, the relationships that are allowed or not among the participants, etc. Right? And then in the case of logo, the graphical activity, the application itself is highlighted by this rectangle, right? So you have like a learner interacting with the graphical turtle on the screen trying to produce a picture in there. And the interaction is mediated by turtle commands and other commands of the language. Save file, load file, and other things. Yeah, that might be destructive in some cases. Right? But the logo itself doesn't support any kind of interaction with the community in here. There's no computer-mediated communication with somebody else. Right? In the process of running a constructionist project, kids have to execute these different kinds of actions. One of them is they idealize a project, they construct something, they assess, then they debug what they've done, to try to find like problems or things that were different from what they expected. But they also are invited to describe what they're doing, you know, in journals, usually on paper. So what do you want to do today? What did you do today? What are your plans for next week? What was hard? What was easy? That kind of thing. And then we expect that in the process of describing, they have to reflect about that. But in many cases, that part is not supported by the software itself. It's supported by paper-based notebooks. So based on these ideas, I implemented a workshop with children that was in 98 or 97 in one of the parks, Central Park in São Paulo. And the goal was to have kids develop games about the park using a software that was being developed by the Apple Advanced Technology Group. Then that later was released as Stagecast. And then this is Coco, like the software that they used. It's very graphical. And interesting thing about Coco is that many people describe Coco as the successor of Logo. And it's a programming language for kids. But it was had the notion of multimedia and internet and other things, very rich in a sense. And it was cool thing is that you didn't have to write the commands on the screen. It was a language that you program, you create your games by example. So like in this case here, you draw like a character. If you want to teach this character how to move to the right, you select the character, and then you open up the little square right to its right here, and then you drag the character. So that the computer would understand that every time that there is an empty square besides the little object, that object should be moved to this empty space. So teaching a little rule in that. And then, for instance, I can teach another rule where you have have the object and then a wall. You select both of them. And then you say, oh, when the object hits the wall, you want it to bounce back to the other side. So you program by example. It was very easy for the kids to get started, and it was easy for me to translate to Portuguese, and etc. So it was fun. So we ran this activity for 2 weeks in the park. And this is the activity, the goal here, right? Described in terms of activity theory. So the subjects were students from that non-profit organization. And they were interacting with objects that were either components of the game, of the software, or annotations that they made using special notebooks for that. And the goal was to create a game about the park. There. And the mediating artifacts were planning sheets, computers with Coco, a camera that I was using, etc. Right? And around them we had some teachers, other students, some people who wrote the examples, etc. And the rules were they have to be on the schedule, they have to write the personal journals, right? And the divisional label is the same for any activity, in the case, I was the facilitator, and they were the learners. In some cases, the learners were facilitators too. The students worked as facilitators, teaching one another. Yeah, but if you want the software to support that, you have to really think how that's going to be done. And these are some of the things that they created using Coco. Like one created some sort of a soccer game. I really like to play ball in the park. It's like a different thing that have to do with leisure or recycling. This here was the student created like a maze made out of trees, and you have to go and find a key here to save a princess that was hiding somewhere, but you also have to run from the thieves. So that they're really concerned about you have to be careful when you walk around the park. This one tried to represent the organization that I was working with. In there, for each square, there's a little characters here at the bottom, and each character represented a person who worked at the organization. Whenever you pressed the mouse on top of the characters, they would either say something or do something fun in there. This one was a game where you have to jog or go running around part of the park, and then you get tired and you have to eat. And then this one was about recycling, where you had to collect different kinds of garbage and move them into these different garbage cans. And this is the kind of thing that they did with the tool. And then
how long did it take them before they were able to create the game?
yeah, so in total it was 2 weeks for this, and meeting once every 2 days with them for I think 2 hours, I think. I had 6 kids.
What age?
Oh, it was open. The activity was I think from 10 to 16. Some were street kids, other kids coming from families. So it's a very diverse group. And one thing that we learned, for instance, they tried to save their program, and then it was very slow. And that was because of the network that we had, and other things. So in this case, we have to always analyze the computers in relationship to the larger context that they're being used. So just to test this software in a lab doesn't really help. You have to really see what are the different things that you might find in a real life context in there. And there's a lot of, when you think about construction, there's lack of tools to support the facilitator. If you have 10 kids working with them and each one is working on a different project, how do you manage that? How do you provide support to them? You know, the different ways that you can perhaps take pictures of the different screens and save them so that you can write your own notes later on. Or there are, you know, I couldn't find many tools that actually support the role of the facilitator in the process. You know, or even like a logo. Every time that you open logo, you have to find your file, you know, and remember where you were the last session. But if you're assuming that kids are going to be working long term in the same project, why not have other facilities that help them, you know, go back more easily to where they were before? You know, just assume that they're going to take many days to do a project. So there's lack of tools to support development of long activities, tools for students to make notes, right? And it's very important to allow time for the appropriation of the artifact. So like the first time, a couple of times that they used the tool, it was very hard, you know, or harder than the third time. But that has to be planned. And so I think when you buy a new tool, it should say, you know, this might take like 2 sessions just for kids to get up to speed with that. But I usually don't see that. But based on the overall research, this thesis here proposed like a framework, right, that address important questions that have to do with educational activities, like a ways to embed the theory in the activity itself. So this is based on constructionism, for instance, which is different from instructionism or other kinds of things. How to represent the important characteristics of the environment, right? The social dynamics that you see in a classroom, for instance, right? How the participants develop over time, you know, as long as they start getting more and more experience with different things. And then how to analyze the computer in relationship to other objects and other things that you see in the environment. But if you look at software engineering in general, you see that there are like methodologies that are specific for real-time machines or software. Like methodologies that are specific for systems like an airplane controller. You know, that had to be very reliable and has to respond very fast. You have other methodologies that are good for data management. You know, so you're gonna create like a system to handle like 100,000 employees, but really manage that information very carefully. Or other systems that handle multimedia. But in the case of education, where you have to deal with motivation and interaction between people and development, how they evolve over time, what they learn, what they don't learn, it was really hard to do. But I think activity theory, at least for me, really helped think about. It gave me like a vocabulary that I can use to think about education, you know, in ways that I think educators are happy about. Too. So this framework also helped organize some of the theoretical concepts associated with constructionism, right? And made explicit the logo characteristics that can be explored for other domains or applications, right? And there's some other questions. Lack of tools to support facilitators, the importance of giving time for kids or the learners to get up to speed with the tools, etc. There are many challenges in building this framework. One is that there are different bodies of theory, and there are not that many references available about any of those things. You know, activity theory is not very popular in the West. And constructionism, there are a few books about that. There's some, but it's not much. And to combine these things and issues of translation and etc. was a little mess. But the community was very supportive. Like I interacted with Bonnie Nardi, who wrote the book quite a bit, you know, and other people who actually did the original work. And they're always very friendly, and that really helped. It would be impossible to do this work without their support. So we propose an approach to develop software for education, revise the concepts of activity theory and constructionism, articulate the theories. But I wonder if this sort of approach could be used beyond what I did, you know, to other theories or other age groups or domains. My impression is yes, but we need to spend some time doing that. So as of '99, I really wanted to write articles about this, help spread ideas, and etc. But I never really had time. Like in 2000, I started my PhD, and then I had to start focusing on different things. and unfortunately my thesis was written in English, in Portuguese. Not many people understand Portuguese. And that was, I think, biggest frustration for me with this work is that I could never really make it more accessible and keep the discussion going about that. But it really drove a lot of the work that I did right after that, and even today, I think, when I think about like in software for kids in underserved areas and etc., I have this framework in mind. And so, for instance, when you're thinking, like one of the things we're doing with the Department of Play is thinking about neighborhood mapping for children, right? And you can represent that activity using the same methodology. So in this case, we have like a learner. It's going to be handling maps, landmarks, and annotations to build some sort of personal neighborhood representation on the screen, right? And it will be using some sort of a mapping tool commands here in that process. So in our application, this is what we're trying to do. Now build a system, right, that's going to let this learner, whoever the person is, right, manipulate those objects through some specific kinds of commands that you have to define which commands are the ones that you're more interested in. For instance, are we interested in helping kids measure distances between houses or number of houses, or just interested in having them record their stories? In that, if I were to focus more on formal education in the school, I'll get like the curriculum of different grades and see how I could map those curriculums into this tool. But in the case of the Department of Play, where I'm interested in civic engagement and personal expression, etc., we think in different ways. For me, so in that case, it's very important to let kids record their stories using audio, right? And letting kids who are not literate have an opportunity to express themselves. So that's the notion of inclusion and participation. That plays a different role. And then how is it that the tool is going to support interaction with the community? So is it like just making maps available online, on the web, or it's going to have some sort of a forum? We're going to have like a chat channel where the kids are going to be talking to one another while they're creating this thing? Are they going to be interacting with like local politicians or adults? These are questions that you have to address in that. And, what is it that they're going to use this? What kind of the size of the length of the sessions? Are they going to use the tool just like for 5 minutes to do a simple sketch, or they want to do something much more complex over a couple of months? Right? So when we design, I think those are important questions that I think the framework helps us think about. So that's it. So if you want to learn Portuguese, once you do that, you can read the thesis, or you can watch the video and get a sense of it.
Did this set of ideas make it into your doctoral thesis?
So yeah, so that's an interesting question, right? Because I think activity theory helped me think about education in general, and then the importance of designing activities to help people learn specific things. But I was trying to figure out what kind of activity is the most important, I think, for people to learn today, like according to the problems that I see in society. And that's a big question that I had, because in parallel to my master thesis, I was directing a non-profit organization that built computer schools in slums. And I couldn't really see the impact of our work in our community. So there was something that wasn't really working in there. And I couldn't figure out what would be an appropriate activity that will help people use computers that are available to them in ways that will help improve local quality of life in there. So that was the activity that I was interested in. So I think in my PhD, I think I spent this whole entire 6 years just trying to understand what are the attributes of that activity, the technology that are going to help people engage more actively with their neighborhood in positive ways. But that's a subject for a different presentation. But in my thesis, I went through 6 or 7 design iterations of the activities themselves. From the Young Activist Network that we ran for 3 years to the WhatsApp Lawrence system that I think had much better qualities for that. So it's the same idea, but I wasn't really focusing on activity theory per se. I was thinking on participatory action research with children was the activity, and then how to describe that and how to analyze the role of computers with it. Any questions?
For me, this topic is so new. I mean, to use computers for playing or for creating things. So, but it's very interesting, and it's great how you did it, and how the research is done. But the question at the very beginning, what is the additional use of? Did you also think about the additional use of playing on the computer, on creating those things that you show, in comparison to playing just normal?
Yeah, so that's one of the things that I find interesting. So when you think about objects, right, and so like when you think about any like this is a generic activity. Let me see. Here, your interaction with objects to do something, right? And these objects can be digital or non-digital. So I think the question you're asking is when should I use digital objects and non-digital versus non-digital objects in there? And an impression that I have is that people tend to use a lot of digital objects because of the attraction that they have. It's easy to attract people because they're flashy, they do interesting things, without necessarily using that for what they're good for, right? In a way, or sometimes they're cheaper, easy to scale, right? You can get the same video and multiply a million times without having to get, which is very different than bringing a real person to talk to you about the same topic, right? So there are different logistical things. And I think activity theory really helps think about the different, when you think about like the interaction with objects and what it brings to you in terms of cognitive development, physical development, etc. It's not going to say what's best, what's not. It's just going to say it's very different. It's very limiting in some ways, and it's very positive, there's a lot of opportunities in other ways. But the question here is really how people think. Are you going to use digital objects for this thing or not? And why? This question that you will have.
So, are you planning to use some of your activity theory work in applying to some of the thinking about some of your projects at this stage now? Do you see a role of sort of bringing it back in?
Yeah, so a lot of the projects that we've been doing for this past year with the Department of Play, they're just things that we identified during my PhD. Like the need for communication tools to help children and the adults work with them, organize events or promote events locally. The mapping tool was something that we needed in most of our projects. So in that sense, they were more mechanical than anything, in the sense that we identified the need several years ago, and now had the opportunity to actually implement the tools. And once the tools are done, we should be able to go back to the activities, and actually implement them, and then really assess what's going on in there. So I think it was a necessary step that had to go to implement the tools, and now go back, hopefully once the tools are more stable, go back like to a higher level, and then, okay, let's use this thing, and let's measure the impact, and make them more available.
So this would be a way of sort of taking a range of the tools and then thinking of them at another abstract level.
Yeah, I
think
maybe
returning back to them.
Yeah, so I think now we're getting to that point, I think, where the tools are getting more mature, that are going to have some space to actually think about the ideas. I love to.
Is there, in your experience in Media Lab, Is there much theory that goes along with the Media Lab work, coursework, and various projects and things of that sort?
I think that depends on the groups.
Okay.
You know, depends on the emphasis of the faculty.
No.
But even inside the same group, you might have, depend on the students.
Sure.
To, you know, who are more interested in the implementation versus the theoretical frameworks.
Mhm.
If the faculty is supportive of that, that's great. You know. But the Media Lab is very proud of a tinkering approach to things,
Yeah.
where like you build stuff,
Mhm.
and then you see what it looks like, and then you see, oh, this might be interesting for this or for that. You know, which opens up things for like it's important in a way because helps people do things that you would never imagine before.
Yeah.
But the other, but you also find some amazing people around that, you know, have very serious research, more traditional research. You know, they go like one tiny step at a time in the same direction. You know, and writing things and sharing that. It's two different
Yeah.
approaches.
Yeah, I can see how both models would be incredibly valuable.
Yeah.
That's one model. You just take and create what is possible, and you step back and analyze it more
Yeah.
and sort of see. Whereas in another, it's more of a assessment of a need or something like that. And how should we approach that need?
Yeah.
But a theory or some kind of theory of how to accomplish it. See both of those being part of the whole scene.
What is your work about?
Well, right now my work is surviving the term.